All right, here we are, 2 hours UTC. Hey, everybody, this is Cosmic, and you are watching Astronomy Daily Live. I just posted a image on my Discord server of the sunset here that just occurred, at least one of the pictures of the sunset that I took tonight. Let me share that. Let me share that really quick, and that'll allow anybody who wants to come on in. Glad to see you again. This is a daily live stream where we gather up a bunch of friends who share a common passion for astronomy, and we sit around and chit chat about everything astronomical and uh, everything awesome like that. And the sunset was, well, most of the sunsets here are pretty spectacular. This one was, yeah, definitely up there in the awesomeness. So I'm just sort of getting myself started here. Let's see, got to start up Chrome over here. Go to my go to my YouTube page. Look at the video. Okay, so now I'll share my screen. Hope everybody's doing well. If you're watching this live, howdy, howdy. I see Uncle Bill is in the house waving. Um, so I'm going to hide that, and I'm going to go over to my Discord server on the live chat channel. Is that where I put it? No, I put it links to awesome. Links to awesome. So there it is. Let's look at the original here, just for fun. So there it was, just maybe half an hour ago or so, something like that. Oh, some reason that thing. There we go. So yeah, this was pretty colorful tonight. So this is a big image here, but yeah, lots of good color, lots of dynamics. Had a little tiny bit of rain today, which is a little unusual for this time of year. But you know, this is definitely not what an astronomer wants to see at sunset. But you know what? If I'm not going to see a clear sky, a beautiful clear sky, I want to see something like that. So yeah, very lucky and honored, to be here and to be able to experience these kinds um, of events. And yeah, I'm pretty pretty awesome. Yet another day, I can't contribute much. Well, Uncle Bill, you're here, and that's awesome enough. I appreciate the support. You've been around since almost the beginning, and yeah, hey, I just appreciate the support. I know, you're trying to spread the word a little bit and get the word out about this live stream, and yeah, I'm trying to make improvements uh, each and every day, and yeah, I'm seeing some small improvements, and sometimes viewership is relatively speaking is up, and sometimes the viewership is down. But I think a little bit of persistence and a little bit of consistency, uh, you know, uh, the fact that I'm here every single day, um, maybe makes the sense of oh, I've got to watch this not be uh, all that much. Thank you, spacetv.net, for reminding me that I need to tweet the fact that I am live. So I'm going to go do that really quick too. Hang with me, folks. As I said, thanks for those who are joining me live. Thanks again for um, uh, those of you who are uh, watching this later. I'm going to try to type and talk at the same time. I'm just saying Astronomy Daily Live is on now. And I'm going to make the link here. Paste that sucker on there. Put a pretty picture on. We'll do this one tonight. Okay, so I'm tweeting that out, and I should put it on Facebook too. So I just tweeted the fact that ADL is on live, and I'm going to do the same thing over on my Facebook page. Uh, let's see, we'll just go with that tonight. Cool. Thank you, Space TV, for that uh, reminder. Because you know, 9 times out of 10. Here, I'll come back to not sharing this beautiful sunset here. You'll have to stare at this thing for a while. But yeah, 9 times out of 10, right? I will have the tweet ready, right? Ready to hit the tweet button, ready to hit the post on Facebook, and Astronomy Daily Live will start, and I'll start. I'm like a rocket, right? I'm just like a rocket, and I totally forget to tweet, and then I go through the entire show and um, uh, finish it up, and I go back to my Linux machine, and it's like, oh man, I forgot to tweet that I'm live now. So yeah, but I'm glad everybody's on board. Join in the circle. This is just a casual, fun conversation about all things astronomy. Um, uh, Also do some science in here. So I like to remain skeptical yet open-minded about about all kinds of things. Um, uh, I I just I like most things, so I find an interest in almost everything. But when I have an interest in those kinds of things, I look at them really, really hard, and you know, as I said, keep an open mind. Um, but yeah, this is just fun. So this is for anybody new, um, any um, um, pros uh, are welcome here too. The amateurs for sure. Everybody, and we can talk about pretty much anything that either you want. You can go to the YouTube chat, Space TV in the house. How's everything going? You are a trooper, being up at 2:09 a.m. Watching this live. I think that's very, very awesome. Thanks for all the support. Um, yeah, I think that's great. Um, so yeah, I guess Skylius is on like every day this week. Is that true? So yeah, um, uh, yeah, I think that's fantastic. So um, you know, don't feel bad, Uncle Bill. You know that you have to support her because she definitely deserves it. And yeah, you know, anything to talk about astronomy and and space and all that. You know, her show is uh, obviously slightly different than this one, um, but she has quite a um, following, and I'm curious to find out what her recipe is for that. Um, but yeah, total support. Check her out. She's over on twitch.tv. It's called Skylias. It's Skylias. And yeah, I haven't watched many of her shows, but I've watched a few. And for one thing, she knows her stuff. She knows her stuff. I'm not quite sure if I like the delivery all that much, but to each his own. I mean that's just me. So people um, like that kind of approach. It does make science and astronomy very manageable, um, sort of approachable, and yeah, she knows her stuff. I don't know what her background is. I don't know how she learned all the things that she uh, um, um, knows and is able to talk about. But yeah, being being in the science of astronomy, you tend to um, do a lot of absorbing of lots of information and stuff. Now tonight, okay, I do not have coffee. Do not have coffee. I do not have dihydrogen oxide. I do not have hydrogen hydroxide. I don't have any of that. I have I have one of these things tonight. This green this green liquid. It's called green goddess, and this is not an endorsement in any way. It's just we were sort of in in the moderately big town where there's a store that has these. So it's like, oh, okay, I got to grab some of the green fluid, and it's this stuff is packed full of stuff, right? It's got spirulina, green tea, broccoli, spinach, barley grass, wheatgrass, garlic, Jerusalem artichoke, Nova Scotia dulse, iron, manganese, vitamin A, vitamin B6, vitamin B12, vitamin C. So it says feel good, and yeah, uh, pretty delicious, pretty awesome stuff. The only the only problem that I really have with it, and you can sort of ignore this to a certain extent, is it's green. It's green, right? And so drinking green things, I don't know. I don't know. But once you get by the fact that it's green, it's very very awesome. I and not that this is really a problem or anything, but I had sort of a similar problem with purple potatoes. When I first saw purple potatoes, I was like, oh man, I cannot even contemplate eating one of those things. It's purple. It's like, but let me tell you something. purple potatoes are probably the tastiest um, potato you will ever experience. It's just absolutely awesome, awesome. So I'm just reading Uncle Bill's stuff. Okay, so she's a computer scientist. BS, yeah, just lots and lots of BS. Cool, cool, yeah, um, cool. So she's a. I wonder if she's a computer scientist or if she's a programmer. There's sort of a distinction there. Um, but obviously, knows her stuff, uh, knows what she's talking about. As I said, she's got a really uh, um, big audience, and so awesome for her, awesome for the science of astronomy, uh, awesome for space. If she's able to bring in people who um, wouldn't otherwise, you know, be interested in these kinds of things, just just because her delivery is slightly different. I think that's great. I think that's great. I am rooting for her. She doesn't uh, really need my support, but she definitely has it. So check her out on Twitch TV, Skylias, Skylias, and um, so so Skylias Cares has lots of singing content. That's cool. That's cool. I'm gonna have to check out her YouTube channel. I haven't done that. Many scientists are also um, into the arts. They're either into music, like myself, or visual art, or some kind of artistic uh, thing, and those two things are definitely linked, and that's why I promote the idea of STEAM as opposed to STEM. Okay, STEM is science, technology, engineering, and mathematics, and I like to add an A into their art, the arts, because science and programming, computer science is very creative, and I think a lot of scientists who aren't into art don't really realize that, but it's absolutely true um, that um, uh, there is a lot of art in science. Okay, so um, 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 Pamela Gay is AWOL. She's in Japan, right? She's traveling to Japan. So yeah, I mean, I think in Japan, right? It's really tomorrow. It's like it's getting around to maybe tomorrow afternoon or so. So yeah, figuring out you know time zones and all that kind of stuff. Although I have to say, okay, I've got to say it, if you're an astronomer and don't have a grasp of time zones, hmm, hmm, bad on her, bad on her for sure. But you know, probably dealing with jet lag and not quite sure what she's doing over there, probably attending some kind of a conference or giving a talk or something like that. So probably busy too. And things can so easily get away from you when you travel. So yeah, yeah. Anyway, so yeah, tonight it's the green goddess. Is that what it's called? Yeah, green goddess, uh, and Yeah, it's quite refreshing. Cheers. All right, well, cool. I wasn't quite sure about any kind of topics tonight. I'm thinking that maybe just what I want to do is go over to let's I don't know. Why don't we go over to let's go over to archive.org and check out sort of the latest bleeding edge research papers in astronomy. If you don't know about uh, archive.org, definitely check it out. Now, archive is ARXIV.org. The X is like a Greek chi. So let's go over here, and I can't say enough about archive.org. It's when this this not only covers um, astronomy, but it covers pretty much all of physics. Okay, condensed matter physics, general relativity, quantum cosmology, high energy physics, mathematical physics, nuclear physics, quantum physics, etc. But then there are papers on mathematics, computer science, biology, finance, stats, electrical engineering, economics, and what these are. The process of getting a paper published is, of course, a scientist writes a paper and they submit it to a journal, and usually um, uh, uh, what happens yeah, usually what goes on then is that paper is sent to a number of um, referees, peers who are sort of maybe experts or know something about what the paper is talking about, and can give some reasonable feedback about the paper. Um, you know, Ultimately saying yes, this paper is good enough, to publish, um, but also providing feedback in terms of, hey, this part here, where you talk about blah 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 blah, you might want to fix that up or sort of expand on it, or you know this part over here really isn't relevant, or this plot of data really isn't showing things the right way, so why don't you do it like this. So they'll make recommendations, um, but ultimately they say yes, this publish or this paper is worth publishing. And there's a lot of controversy about peer review. Whether it sort of stifles um, uh, new things a little too much. Because if somebody comes up with some kind of wild theory that's not the norm, thinking outside of the box, then the referees are going to look at that and say, well, this is garbage, right? Don't publish this. So, and I think that probably happens. Um, but I I guess the hope is that um, you know these people are scientists, which means they they want to have uh, um, uh, you know, as open a mind as they possibly can. So hopefully they don't, stifle a lot of the new things. And as you read through, the papers, at least in the astronomy part, I'm seeing a lot of variety and hopefully some new things. So Space TV asks, what for you is the most interesting mystery relating to your work? My work? Hmm. Well, my work is sort of all over the place because at the moment I am a independent um, research astronomer, so I can sort of choose uh, what I want to be doing, and so really the short answer to your question, Space TV, is that right now I'm not really dealing with any mysteries. I'm dealing with problems, but I'm not really dealing with any mysteries. Um, the current problem that I'm dealing with right now is that I want to be able uh, to properly stack um, a bunch of images that I've taken with my telescope and CCD, and I've got two problems. The first the first is an easy problem to solve. The second one is turning out to be a little bit more difficult than what I remember, because I've done this before. It's probably been 15 years or so. So the first problem is that this telescope um, doesn't track very well. I don't have any kind of auto guiding. Um, so I can take a 1 or 2 or 3 second exposure and all as well. But if I take like a 10-second exposure or like a minute exposure, 2 minutes exposure, it's all I get are these weird looking, they're not even really streaks, right? Because the tracking is just all over the place. So I have to take a series of short exposures, 2 or 3 seconds max, um, and each image, um, if you sort of imagine like a field of stars, right? Well, because um, um, the tracking isn't all that great. Um, one image, will have the stars in a certain position, and then the next image, all those stars will be shifted around, and the next image shifted again, and so 20 or 30 of these images, they're shifting all over the place. There's sort of a drift, and there's a shift, and all that. That's easy to fix. That's easy to fix. The other problem that I have to deal with is field rotation. Since my telescope mount is an alt-az mount, um, and I'm not an equatorial mount, I have to deal with field rotation. And so not only do I have to, you know, shift these images around in order to stack them, I also have to rotate them. Um, and it's the rotation code that I'm having some trouble with. Now, as I said, I've done this before, and that's one of the things that's sort of frustrating, um, at least at the moment. Is I've done this before. I've you know uh, but I'm working through it now, and it's not working right. So, as I said, it's not really a mystery. Um, it's just a problem, and you know I treat it like an obstacle, that has to be climbed over, like a wall. And I'm just, climbing the wall, and I slip and fall off, and I start to climb again and climb and climb and climb. Eventually, I'll get over it, and all will be well. The cool thing is that once I'm able to do this and properly add up these images, uh, the signal to noise is going to be greatly increased, and I'm pretty sure that my photometric measurements will get uh, very nice. The accuracy and precision of those measurements are going to be very small. Um, I want to do like less than a tenth of a magnitude if I can. Uh, the smaller, the better, of course. 50 millimagnitudes would be totally awesome. 0.05 magnitudes would be would be absolutely great. Yeah, I've got a Celestron Nexstar 8SE Schmidt Cass, and um, the CCD that I'm using is a SBIG ST7ME. So it's a it's an older CCD, but it's 16-bit, and it is a workhorse, and it's extremely awesome, and uh, it definitely delivers the goods. In terms of astrometry, I'm getting well, my pixels are about 1 arc second in size, and the astrometry I'm getting in terms of accuracy and precision are about 1/3 of an arc second. So that's about a third of a pixel, which is about as good as I can expect um, in terms of astrometry. Measuring the positions um, of targets in the field of view. So yeah, photometry is a lot harder, and as I said, I'm having to deal with a little bit of post processing. I'll get through it. It's no big deal. I just have to wrap my head around it, uh, and basically remember how I've done it in the past, and yeah, I'm on it. I'm on it. It's just going to be a couple more days, I hope. So, cheers. All right. So archive.org is very awesome, and as I said, okay. So once the referees uh, um, give this the okay, then it goes through a process where the journal has to actually decide if they're going to publish it or not. Usually, if the referees say yes, uh, it'll be published. Um, and so there's sort of a back and forth there, because the copy editors have to get involved, make sure all the spelling's right, make sure all the pictures are in the right place. It's sort of a back and forth game with the authors, making sure the formatting is right and blah 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 blah. Um, Once that's done, then the journal can accept the paper for publication, and at that point, it sort of um, gets put on the list, right? And it could be a couple weeks or a couple months before it's actually published um, in the journals. But in the meantime, the preprints of these can go up on archive.org. And so as soon as the paper is accepted for publication, it can go onto this site. And all these papers are free, and they're in PDF format. There are other formats as well, PostScript and probably LaTeX and um, maybe others, but PDF, is sort of um, the standard. So rightly so, astrophysics is right at the top, and these are updated every weekday, just a little bit after 0 hours UTC. So the fact that right now it's the weekend, there aren't going to be any new updates, but we can look at sort of the recent ones here and just sort of go through them. And usually there are at least a couple of dozen new ones every weekday. And this is just in astrophysics, right? As I said, there's all the other physics, there's all the mathematics, there's computer science. I mean, you can just be completely buried uh, in these things. So, uh, what I like to do is I just sort of like to go through them from time to time and see if any of the titles catch my eye. And here's sort of an interesting one on the age of the Nele asteroid family. Now, I have absolutely no idea what the Nele asteroid family is. I'm going to take another drink of my green goddess here. Cheers. By the way, Space TV, I am located in southeastern Arizona, which is one of the darkest places on the planet. Um, I typically have a sky magnitude of about 22 or so. So I've got a very, very, very dark sky, which makes you know doing these kinds of astronomical um, um, observations very, very awesome because I can see you know 2 second exposure. I can easily see like a 12th or 13th magnitude star. Uh, and if I stack a few of these, I can see to 16th or 17th, no problem at all. So I've got a very, very, very dark sky, which is completely intentional. Uh, yeah, I like the dark. So the age of the Nele asteroid family. So obviously, there's a population of asteroids out there that have some kind of characteristics that put them in a group sort of all their own. So let's just take a look. So this was just published on Friday. As as you can see, the preprint is for the 23rd of March, 2018. So this is like brand new, hot off the press. Uh, let's see, these guys are in Brazil, the Czech Republic, and in Colorado. So the Nele group, formerly known as I'm not even going to try that one, is one of the youngest asteroid families in the main belt. Okay, so the main belt is just all all the asteroids between Mars and Jupiter. Previously, been noticed that paracenter longitude and nodal longitude of its largest member asteroids are clustered, therefore suggesting that the collisional breakup of the parent body must have happened recently. Here we verify this conclusion by detailed orbits propagation. So they create a model, um, current level of clustering, blah, 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 approximate age limit of 4.5 million years. Additionally, we make use of updated and largely extended Nele membership to obtain for the first time an age estimate of this family using the backward integration method. Okay, so more models, proper orbital elements. Yeah. And there's a lot of those. Like the Trojans are the ones that come to mind. Um, those are the ones that are both leading and following Jupiter, right? That's a family. Um, Lots and lots of families. This one looks like they're thinking that it it was sort of formed from a single um, parent body, like 4.5 million years ago, more or less, somewhere between like 4.5 million and 7 million. So that's at least in the current thinking of how the solar system formed and evolved and all that, which is just a guess. We don't know for absolute certainty, but that time scale doesn't seem very long ago. Asteroid families form as a result of collisions among asteroids, orbits of the fragments, blah 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 blah, young asteroid families. So in this work, we focus our attention on the case of the Nele cluster. This family, previously also known as that. So probably one of the first things that they have to do is identify, um, yeah. So family identification. So they have to figure out which asteroids are part of this family and which ones aren't. Now, one of the really cool things about all these papers is the references, right? The references are are sort of your bridge to history. Uh, they uh, these things references will discuss specific topics, and so you can pretty much start with any paper like this, and just by jumping references, you can get into the history of these things and go back and back and back and back and back and you know just get completely buried, right? I mean, all this. You'll also recognize names come up often, like this name, which I'm not even going to try to pronounce, but this person obviously uh, is deeply involved in either asteroid studies or is some kind of expert with the Nele family. I can imagine how. Yeah, I think those are um, like Lagrange points. Um, the Earth has has those too. There are um, uh, some asteroids. I don't remember what the angles are, but there there's a family of asteroids that leads and follows Earth as well. I'm pretty sure that those have been um, 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 those have been seen. So I think, well, I can't say all the planets, but I would probably, I mean, I'm certain about Earth, Jupiter, pretty certain that Saturn has them too. Um, don't know about the other ones, but my guess is that yeah, most of the planets have have these kinds of things. And Lagrange points is pretty much what they are. They're just some kind of resonance or some kind of you know zero force area where gravitational forces are balanced in some way, and so these objects wander um, to these areas and sort of get stuck there. Wasn't there? Um, I think there were a couple of Star Trek episodes about that. Them getting stuck in an area where it's like they can't get out. Anyway, so let's see. The Nele family looks like it has about 150 members. Um, uh, Cut off to obtain a family of 150 members, which is 8 times more than the 18 members available at the time of this paper. Um, so it looks like they found more. Let's see. These guys say 344. So yeah, there's, I guess, as with everything, there's a little bit of controversy in terms of how many members there actually are. But yeah, at least a couple hundred or so. Usually we use, let's see, the family is very compact and isolated. So we identified objects in the local background of this group. We used the synthetic proper elements from this site, the ASTDYS site. See, that's what I mean. These papers, all these papers are like jumping off points into other areas that are just I mean, for me, they're just sort of begging. It's like, come on, you got to check this out too. Lagrange points with the sun, say, or some kind of resonance, resonance with um, Saturn, say. Uh, yeah, there's all kinds of weird things out there. Awesome too. Let's see. Selected orbits with values. I don't know what. Oh, okay. Eccentricity. Proper E. Yeah, guess so. Let's see. Values of proper A. I'm not quite sure what proper A, proper E, all that is. I know about just regular E and V sine I, which is just the velocities. A is just that's the semi-major axis, I believe. So yeah, they're situated right in the main belt between 2.638 and 2.651 astronomical units. Let's see, 81 additional background objects. I want to see how did they detect these things. I don't know. I don't know if they were using a catalog already existing or if they made their own observations or if they just grabbed this information from previous studies. I don't know. Let's see. Oh, let's move on here. Better understand the role of chaotic dynamics, we identified asteroids at different ranges of the LCE. Um, so many jumping off points here. So many things that I don't have a clue. These are one of the papers that just completely fly over my head, and but I like that. As as long as it's not flying too much over my head, I'm okay with that. Especially if these papers have pictures in them and stuff, because pictures I can sometimes get a relatively good idea about what they're talking about, even if the words don't make a lot of sense. So these are pretty bright. They have an albedo of 0.32. So, 32% of of the light is, that hits them is being reflected. So that's actually pretty bright. I think a lot of asteroids don't have albedos larger than like 5%, 10%. So the fact that this is, you know, 32%, that's pretty bright, pretty bright. It's sort of looking like these guys are pulling this information from other sources. They're not actually making their own observations. They're going into, catalogs, right? Like the Sloan moving object catalog, Mach 4, as they say. Um, let's see, of the 7 objects with taxonomic information based on broadband SDSS data, 4 belong to, okay, so they actually identify these asteroids. I don't recall what K types and Q types and S types are, but again, that's sort of a jumping off point. So yeah, the 14 objects in Y's albedo, only 2 have an albedo less than 0.2. So yeah, these are very, very bright objects. Uh, so Nele itself was classified as a TD object. What's a TD object? Oh, I don't know. See, it says TD type. I don't know what a TD object is. Sorry. So many things I don't know. Okay, so here's some eccentricity, which is just um, um, how much of an ellipse it is. The larger the number, the closer it is, to being like a parabola or a hyperbola. The eccentricity of the Earth is very, very small. Let's see if we can get that. Eccentricity of Earth. So the eccentricity of the Earth's orbit is currently about 0.0167. So it's almost a circle, right? So the fact that these are at, you know, somewhere around 0.2685, okay, highly eccentric. So um, uh, they come in, uh, well, relatively speaking, they're coming in, close to the sun and then going way, way, way out and then coming back in. So let's see. Um, so yeah, so this is just a plot showing how far away they are on this axis in astronomical units, and of course, an AU is the average distance between the Earth and the Sun. So these, there's a pretty good, well, I guess a relatively, that's pretty narrow, I guess, 2.64 to 2.647 or so AU. Yeah, so they're sitting around 2.6 AU from the sun in terms of the semi-major axis versus um, eccentricity. And then this one is the same major axis, semi-major axis, uh, versus the sine of the inclination. So not quite sure why they put it in terms of the sine of the inclination and not just the inclination. Don't know. That seems to be pretty highly inclined because if I do an inverse sine of that, let's see, let's just look at it like 0.212. Okay, if we do an inverse sine of that, sine 0.212, we get about 12.24 degrees of inclination or so. And there's a pretty good spread there too. Let's see, the Nele family member. Okay, so the blue dots are members of the Nele family. The background asteroids are black dots. I don't see any black dots. I see blue dots and oh, are these? Oh, okay. These are these little tiny little black dots here. Man, there we go. Can we see that a little bit better? Little tiny little black dots. You see them here? So those are asteroids that aren't members of this group. I think I zoomed in a little bit too far. Um, for comparison, the red dots display the orbital location of the asteroid family. The large full green dot shows Nele itself. So there's Nele there. What are the blue dots again? Nele family members. The red dots display the orbital location of the asteroid family. I'm not quite sure what the difference is there between those two, but yeah, I can be pretty dense. I'm probably just being dense about these kinds of things. Projection of asteroid on the local background of the Nele family objects. Whew, yeah, this gets really complicated really fast, huh? It always does. Things, uh, especially astronomy, is definitely not a simple thing. Actually, you can make it as simple or as complex as you want. But if you want to do a deep, deep, deep dive, you've got to get deep into it like this. And this is crazy, crazy deep, right? I don't have a clue. But I sure like looking at the plots, looking at the pictures. These are just showing distributions, um, and yeah, I mean it's a pretty tight distribution, right? I mean these things, uh, really don't go very far away from one another, and all their inclinations look to be more or less the same. So yeah, kind of interesting. Age estimates. What else we got here? Oh man, more weird looking plots. So the V shape in the A, comma 1 over D domain of the Nele family. The black full dot displays the location of Nele, largest member of the family. Whew. Oh, I don't know. These units are inverse kilometers. Oh man, who knows? I would have to look at this much harder to really understand that. These planetary scientists, man, they it's this is pretty far out stuff, pretty far out. If there are any more pictures, this is a long paper too. Members of the Nele family, omega with a line over it, and capital omega are oscillating values. Uh, okay, so these, not exactly sure what units These are down here, but these are obviously some kind of brightnesses. So you can sort of see where they lie here, and it looks like maybe they've identified, I don't know, a couple of populations here. Um, the horizontal line, okay, that just shows the 16th magnitude. So somehow that is significant. We'd have to dive into the paper here. The horizontal black line indicates the current values of these standard deviations observed in the sample. Okay, yeah. Phew. Fast convergence of the secular angles. Sometimes Astronomy Daily Live goes into very deep, bizarre realms. Hope you're hanging with me. It's um, this is how we learn things. At least this is how I learn stuff. Is that I dive into things that I don't know anything about at all, and try try to understand it. And yes, it can be you know very intimidating and very um, off-putting, but it it gets me pretty excited because I just want to know more, right? I mean, I want to dive into this and see, what don't know. So okay, so this is evolution of the paracenter um, versus time in millions of years. I don't remember what the paracenter is. Oh man, I'm just failing miserably tonight. But these are all models, so these aren't based on any kind of observations per se, except you know the information that we have now, and based on the information, the data that we have now, we can throw that into these models and do things like this, where we try to figure out the characteristics of um, this family of asteroids as time goes on. And it's crazy. Look at that. It's just wild. I don't know what's going on there. You've got just wiggly lines, and I don't know. But I like it. Oh, time behavior, the standard deviation of the absolute value of differences. Wow, man, they are really talking some pretty complex abstract stuff here. That's pretty awesome, though. So paracenter difference, nodal differences. Hmm. Time behavior, variable defined for differences. Phew. Yeah. If there's any more pictures, these these guys are really talking some complicated things here. Where the thermal accelerations are taken into account. At each time step, 1,000 years, we selected the optimum Yarkovsky drift rate for each Nele member. Phew, wow. Some kind of a distribution there. Let's see. Okay, so we revisited the Nele family membership by using the most up-to-date catalog. It's a very complex or compact cluster of asteroids in the central main belt. Let's see, no other important asteroid clusters were found in the Nele vicinity, making thus the analysis of the family easier. Okay. little bit of chaotic behavior of the orbits. Probably not too surprising there. Semi-major axis drift rates versus diameter. Okay. We also reviewed the physical properties of asteroids in the Nele region, finding the available data are still rather scarce. Okay. Nele family is rare among its class by indicating statistical clustering of the longitude of perihelion and node in orbits of the largest members. This property includes or indicates its youth. So it seems to be a pretty young group. So whatever happened, it happened recently. Inspired by previous success. Um, so there's some other families, right? Karen and Veritas. Uh, so there's another, jumping off point there. Find out about those guys. The age estimate, family by numerical propagation of its orbits backwards in time. Um, Reasonable limit, we concluded that the Nele family is 3.6 plus or minus 1.6 million years old. As expected, the second model, 342 asteroids. Analysis confirmed the very young age. Yeah, and the albedo maybe indicates that too, because they're so bright means that, at least the stuff on the surface is still, relatively new, hasn't been, bombarded uh, long enough, to darken it. Uh, Very young age, improvement in Nele age. For instance, if we know the obliquity values, some Nele members, sounds like just, what'll help and what usually always helps in these cases is more observations, more observations. So, yeah, you know, um, assuming that high quality, sparse photometry from ground and space based upcoming surveys will become available. Yeah, so, LSST, we'll probably see these guys. Yeah, depending on how bright they are, even my scope, I might be able to pick those out. Who knows? I'm going to have to check those out a little bit. I'm going to look for Nele and see how bright it is. Maybe I can see it in my scope. I don't know. If not, maybe like scopes like SLU, um, might be available, to make those kinds of observations. Right. Well, we are past time. We are past time. So, see, I mean, going to archive.org and just looking at the titles, um, that that one just sort of popped out because I know nothing. I know nothing about um, that kind of stuff at all. Well, maybe a little bit, but I like the process of discovery and just finding out things. And as I said, these papers are great jumping off points into all kinds of other realms. So if you're into that kind of stuff, like I am, um, then you can spend days and days and days and weeks just with one paper, just jumping off, going into other realms. It's it's very very awesome, and it's so cool. It's so cool that just us common folk have access to that kind of stuff. And this is new research. It's new stuff, right? This just came out. just came out on Friday. I mean, it's brand new stuff, and it's very, very cool. Very, very cool. All right, I'm going to get out of here for now. Appreciate your time. I I do greatly respect your time. Don't like to go more than about an hour ish or so, um, since this is going on every single day. There's no reason to take up any more time at all. This is casual. This is fun. Um, there's no reason to try to pack in, topic after topic after topic. Um, we can dive into one thing, and look, we just scratched, barely scratched the surface on just this topic alone. The Nele family, and uh, obviously, there is a lot more, that can be, learned about this, and discussed about it. Uh, so yeah, I'm just scratching the surface because I want to talk astronomy every single day. So all right, I'm gonna get out of here for now. Thanks for coming in. I appreciate it. Make sure to subscribe if you haven't already. Hit the thumbs up, hit the thumbs down, whichever you prefer. Make some comments down below. I like to see those. I will respond to those, of course. Make sure to share this around. If you know anybody who has an interest in astronomy, and has some questions, or wants to talk about a particular thing, I am totally game. This is a circle of friends, right? So it's not really just me saying, okay, we're going to talk about this. Um, if nobody brings up a topic, I've got tons and tons of topics in my back pocket at any time. So the science of astronomy is pretty much about everything. So from the very, very small to the very, very large, to the very, very short time span, to the very, very long time span. So it covers, pretty much all space and all time. And what else is there? so, so yeah, we can talk about everything here, everything. Um, as long as you limit it to astronomy. So that is the only requirement here. All right, I'm going to get out of here for now. Thanks for the chat. Greatly appreciate it. Um, and yeah, I'm going to get out of here for now. Take care. Peace. Cheers. Have a great evening, a great day tomorrow. And yeah, I will see you again in a little less than 23 hours. In one day, in 24 hours, okay, we move um, sort of in three major ways. Okay, we are standing on this planet, and we're going around the planet once. Right, that's one day. The Earth is also moving around the sun, and the sun is going around supposedly the center of the galaxy. And in that day, if you add up all three of those motions, we'll have moved about 20 million kilometers. So somewhere out there in space, we will meet again, 20 million kilometers from where we are right now. And isn't that an amazing thought that we are hurtling through space at roughly a million kilometers per hour? I think I it's just that's just dizzying to me. Of course, that motion is all relative, and we're so used to it. We barely, I mean, I I don't know about you, but I don't feel it, at least much. But when I think about it, it's like, whoa, hang on to your hats, right? Because there's quite a breeze at 1,000,000 kilometers per hour. So, all right, I'm going to get out of here for now. Piece, see, that's sort of a double piece. See, there's this piece and there's this piece. So, double piece, single piece. All right, I'm going to get out of here. See you in 20 million kilometers. All right, take care. Bye.